So, hello, welcome to our last Brno before summer. Today we have Jaromir Hamala talking about something impossible, I think, which is missing from the title now.
Well, the title was clickbaity because, to attract you here. You are already here, it doesn't have to be clickbaity.
And you don't see it, but we actually have very nice room today. So please help yourself to food and beer at the back, or non-alcoholic drinks if you are driving, unfortunately. And enjoy.
Yeah,
Floor is
okay,
yours.
perfect. Martin, thanks for having me here. Friends, let's start. Let's get started. Who I am? I'm Jaromir, Jara. I like everything about performance. I consider myself to be a generalist, but with bias for performance. Last 3 years, I've been playing with QuestDB, which is the topic of today's talk. Before QuestDB, I worked for Hazelcast, and I don't know how many people from Red Hat we have here. Okay, just a few, but think of Hazelcast as something like InfiniSpan, but better and easier to use, of course. And before that, I used to work for a UK-based consultancy called C2B2, which you don't know, it doesn't exist anymore, but it's the birthplace of Payara, the application server. Again, if you are from Red Hat, you probably know it. And before we start, one interesting fact. I consider myself to be an engineer, right, a geek, a nerd, but my longest lasting impact is in the field of marketing, because actually I came up with the name Payara while working at C2B2, and somehow, it's stick. So that's, I think, I don't know if I have a line of code still in production after I don't know how many 12 years, but Payara is still around, so you can call me a marketer. But today, no marketing, almost, except this one slide. What is a QuestDB? Have you ever heard of QuestDB other than the abstract? It's a open source database, time series database. Means there is some, again, bias or twist for, it's a twisted towards time series. We'll see what is it about. It supports SQL as a query language with some dialect, which makes certain kinds of time series specific queries like more convenient, readable. You will see it. It does support the Postgres wire protocol. It means you can take a Postgres client, connect it to QuestDB, and it will probably work. I said probably because sometimes people make a mistake that they assume that it's a drop-in replacement for Postgres, but faster. That's not the case. We use the same protocol, but we are not a transaction database like Postgres is. We are more like analytical database. We don't support all types. We have different types. We don't support all functions. We have different functions, yada, yada, yada. So it's not that you have a Postgres, you replace it with QuestDB and you're good. No, you are not. You need to, the use case is different basically, and the reason why we support the protocol is to basically piggyback on the Postgres ecosystem. And for the same reason, you can use Postgres. You can use Postgres for ingestion. It means inserting, SQL inserts to insert data to QuestDB, but it's not the fastest thing. If you want to have really fast ingestion, then we support the influx protocol. If you know InfluxDB, then if you have influx client, or we have our own clients as well for this, then you will have fast ingestion. And last marketing slide, what I mean by fast. By fast ingestion, I mean being able to swallow, hopefully store, millions of rows per second. And what I mean by querying, fast querying, I mean being able to query billions of rows on a single machine in tens, hundreds of milliseconds, maybe sometimes seconds. Of course, this very much depends. And I have first demo, so this is still part of the marketing thing. So this is a public demo running on demo QuestDB.io. You can go there even on your mobile. Please don't crash it now. And we have a bunch of tables. One of the tables is called trips, which is basically a list of New York City taxi trips from 2009 to 2019, 10 years worth of data, about 1.6 billion of rows. If you want to see the schema a little bit, there's quite a few columns, actually a lot. The important thing is that there is some pickup timestamp and some parameters, and just to see there is really 1.6 billions of rows. And if I want to see all trips in January 2009, I can see that there is about 13 millions of them, and the execution time was 2 milliseconds, which is not bad, but this is cheating, right? Because we partition data by time, hence to tell how many rows is there in this particular month, it's easy. So a little bit more complex, difficult for database query is this one. Okay, so still from the same table, I still want to see just the January 2009 trips and total amount. I guess this means how much it cost. I'm not sure. Some kind of filter over $150, I guess. So here we need to do the actual filtering, and still the execution time was about 34 milliseconds. And there's no caching, right? This is not pre-filtered. The only caching going on here is operating system doing a page cache for the raw data file. But still QuestDB has to read the data and needs to apply first this filter, which we know is fast, and then this filter, and it can do it. Yeah, go ahead.
Two questions. Yeah. First, maybe if you could specify like what the time series database is. Why I'm asking, like from what I know, the time series database is that like it strictly partitions data by time, and it does things like compaction of certain value, like during the time, and the time aspect being like the primary one. You've clearly mentioned that it's mostly an analytical database. Yeah. I wouldn't call Influx, for example, an analytical database compared to something like Apache Peanut, for example, right? So if you could clarify that, and then the second question, you are showing it like that runs on a single node, right? I assume locally. Even though you can run like a distributed environment and things like that, right? Or is it strictly local single node database?
The open source version is single node strictly.
And do you have some comparison to something like DB? You know, the latest trend?
Yeah. Okay, let's start with the first one. What is a time series database? It's a indeed analytical kind of a database. Analytical database means it's not like Postgres, where typically the queries are update raw, where some primary key equals something, and basically there is typically index lookup. It will find one or very few rows, and then it does something like update or select. Analytical, so that's called a transactional database.
Yeah.
OLTP, Postgres is Oracle, nice, well-known examples, MySQL. The other category is OLAP, analytical database, where the shape of queries is different. Instead of using index or if there are any predicates, they tend to be non-selective. So instead of where some primary key equals some unique or almost unique value, you do filtering by less selective predicates. Here I'm filtering by date. Okay, it's still, I think it was like 13 millions of rows, and then some, something else. Again, this is not an index lookup, right? So, and that was what I just described. It's not a definition, more like a description of an general analytical database. The twist for time series databases is that time plays some kind of a critical role, right? So here I'm filtering by time. I could have another query which will aggregate by time, right? So I could have a query which says, okay, so take all the trips you have, bucket them by time per month, and calculate the most expensive one within each month, and the cheapest one and average one, right? And by time, if time plays some kind of a critical role, then it may or may not be, but it may be a use case for a time series database. So, long story short, time series databases tend to be specialized analytical databases, right? They are not generic. If you know ClickHouse, ClickHouse is a BigQuery, Snowflake. They are general purpose analytical database for any kind of queries, time-based or not, right? Time series database, or some of the time series databases are like a subset of analytical databases. And your point about Influx, indeed, there are two kinds of analytical databases. One is more like for operational data, kind of like Prometheus. If you happen to know
Yes.
InfluxDB, you typically throw metrics collected from your hardware, CPU, and whatnot.
Values from sensors and something.
Yeah. And then, well, you look at it only if something goes wrong. Or depends, right? And the other kind is like more businessy kind of database. That would be us. That would be timescale, if you happen to know that. That's basically an extension to Postgres. I think they just renamed to Tiger Data or something. And they are oriented towards more like storing and analyzing business data.
Yes. So in this case, we can say that QuestDB is an analytical database which happens to be really, really good when working with time.
Exactly.
Okay.
Perfect. And what was the comparison?
Comparison to DuckDB,
DuckDB.
performance-wise.
DuckDB is an analytical database, all up. Single node is like SQLite. It's not a server. It has there is a single writer, right? They don't have specialization to time series, or they have some very basic ones. They are very fast, right? So for some queries, DuckDB will be faster.
The reason why I'm asking that, like, this is actually pretty well-known data set, right? Which everybody uses.
Yeah. So DuckDB will be faster if time does not play a significant role in the query, right? Then DuckDB will be probably faster in most of the queries. QuestDB will be faster if time plays some important role. But as always, do your own benchmarks.
And I suppose you also have, like, QuestDB does have support for like multiple writers, like multiple concurrent writers, things like that, which DuckDB doesn't.
Yeah, exactly. DuckDB, you have one writer and everyone has to wait. Like SQLite, I think it's similar model. All right. So, end of marketing. I'm terrible marketer, as you can tell. How is it written? So 19% of the code base is in Java. That's the reason I'm here and not in some other meetup. There are bits and bobs written in other languages, mostly C, C++, Rust, a little bit of assembler. But our Java is very special, and that's again the reason I'm here, because I thought it could be quite interesting. And typically, when we have talks like this, by the end of the talk, there are people, why do you use Java at all? You know, your Java is super non-idiomatic. Why would you pick Java to write a database anyway? It's silly, isn't it? Our answer is that one, Java is great. There is community. You know, we have a meetup here. People know Java. Tooling these days in other languages is better, even in C++. Rust tooling is quite good too. But back then, when QuestDB was started, 2014, that was not the case at all. No, Rust wasn't even in version 1.0. C++ tooling was horrendous. I hate CMake. Do you like CMake? No, nobody likes. Nah, come on. do you like AutoTools? No.
Like, if you compare it to the other options in that language area, CMake is actually quite good.
And of course, Java and its famous JIT compiler is excellent, right? I already basically mentioned that. QuestDB, the initial commit is older than the 1.0 version of Rust, because I think nowadays, if the original founder was starting a new project, like for database, he would at least consider using Rust.
Well, I missed it by a year, so.
I think the very first 0.1 release of Rust was in 2013. So technically there was some Rust already existing in April 2014. But I think nobody outside Mozilla.
I haven't heard of Rust by then.
Yeah. Well. Okay, so to make things fast, the founder sets some set of principles every QuestDB developer has to adhere to, right? One principle, no allocation, no object creation, instantiation on a host path. Every developer, when writing a data structure, should be aware of the memory layout, how is it laid out in memory, that particular structure. Another principle is that, related to the first one, if you have some core infrastructure, some collections, utilities, cannot allocate. And the last one, which is again a consequence of the first three, is no third-party Java libraries, because typically they don't adhere to these first three principles, right? They, not always, there are some exceptions, but a typical Java library will not care because allocations in Java are cheap. Normally they are. Maybe the most important reason is that the founder of the project has a background in high-frequency trading. He's based in London, and high-frequency trading firms, if they use Java, they typically, this is their bread and butter. That's how they use Java, right? So that's what he knew, and he wanted to try to apply to a database. The other question, another question we often get is, who cares about GC? You have modern garbage collectors. You have ZGC. You have Shenandoah by Red Hat. Azul has had the C4, low pos or concurrent garbage collector, for ages. So why do you care? Just allocate the object, throw it away. The answer, again, from the high-frequency trading background is, even if you have concurrent garbage collector, it means it's running concurrently with your business app. It still costs CPU, right? It's not for free. It doesn't stop. It doesn't stop your application as some kind of a stop-the-word collector, but it is still, you competing for resources such as a CPU or memory bandwidth, and it costs you even on throughput, because concurrent garbage collector, they tend to insert barriers into your object graph. So when you are writing or reading to object, sometimes there is additional work which you don't have with non-concurrent garbage collector. So even with modern, basically the gist is, even with modern GC, it's not for free. And the principles, they lead us to three disciplines, right? Memory discipline, okay, don't allocate. Certainly not on Java heap. If you have to allocate on a hot path, then do it outside of Java heap, so the GC will not even know it, and will not have to do that much work. The other discipline is execution discipline, right? So you need to be smart with JIT. I will show you what I mean by that. We do some bytecode generation to make job of Java JIT easier, and concurrency discipline. So we prefer log-free algorithm. There is some sharding, more on that later in details. Let's focus on the first discipline, memory. Before we do so, I would like to split a database, any database really, into two big blocks. Front end, which is the part which will receive your query language, SQL in our case, and some planner and parser, lexer, optimizer, blah blah blah. And this front end, so the input of the front end is SQL. The output of the front end is a generated plan, right, which is then executed by the backend. And the way how they are implemented, these two parts in QuestDB, it's quite, each part is quite distinct. So on front end, which is the part which receives SQL, it's pure Java, mostly. There are even some allocations sometimes. We try to avoid that, but sometimes it's inevitable. There is a lot of pooling, object pooling. So we pre-allocate some objects upfront. We give them to a pool. Then when SQL parser needs a new instance of a node, you take it from the pool, use it, spits out the plan, and then clear the pools. We will see this is in an example. In the backend, that means once we have the plan ready for execution, then the backend is quite different, right? The plan tends to not rely on pooling. It's mostly, it does, if it needs some working memory, then it's often Off-Heap, Java Off-Heap memory. Still process heap, but Java Off-Heap. It's used more for like long-lived data, because if you think about it, if I'm a database, you send me a query, then I need to do a lot of work to parse the query, generate, blah, 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 blah. But it's a lot of work, but it's short, right? It's milliseconds, typically. But then, once the query is created, then I have, say, I'm a Postgres client, and I send you a query, your database, you parse it, and then I will tell you, hey, database, give me first 100 results, because I'm doing paging. So you give me first 100 results, and then you, as a database, you keep the plan with its state still in memory. I process the results. I'm slow. I'm Python or whatever, and then I ask you, okay, how do your QuestDB server give me another page, another 100 results, and this can take a long time, right? So that memory tends to be long living. And once, even when I'm done with that particular query, I might execute it again, but with different parameters. If you use, for example, binding variables and whatnot. So in a nutshell, frontend generates and uses some short-living objects. Some of them are pooled. Backend is more like long-living stuff. Off-Heap memory. We will see this later. I don't know if this is readable, but because of our principles, we tend to avoid even Java standard library, because it allocates. You have Java util hash map. You want to store integer, and it costs like 20 bytes and object or something. We have QuestDB standard library. This is a small subset. What it gives us? It gives us I/O. We don't use the old Java I/O, not even the new I/O, not even new I/O 2, sorry. Because who likes that? It's some kind of what's that pattern? Decorator, something, and then you have buffered, and it's yuck. So we have our own implementation of I/O for both files and a network, written in a C, and it's really very similar to standard library in C, POSIX. Like you have a descriptor, you have a receive method or send method which accept that descriptor, pointer, length, does it things, done. I can show it too, maybe. Didn't prepare this, so. See, that's our I/O. That's the file descriptor, which is the socket basically, and then okay. So receive from this file descriptor, and use this pointer pointing to the Off-Heap memory to store whatever you receive, and bear in mind that you can store at most this length, because that's the size of that buffer the pointer is pointing to, right? And if you happen to know the POSIX interface, you will know these methods, right? Okay, collection, that's clear. We don't want an object to store a primitive. Maybe in the future version of Java with what's called Valhalla, we will have some specialization, and maybe this will not be needed in 20 years or so. For strings, who happens to know the har sequence interface in Java? Some? I didn't know it before joining QuestDB. Basically, it's an interface which is implemented by string, except it's an interface, so you can have your own implementation. So it's not a class, and then there is the important method for string, which is har at position. Let's have a look. See, bloody hell. No, the important method length, and then har add to string. Oh, that allocates. No, can't do that. Yeah, and this is implemented by string. If I open, what's going on? And you'll see it implements the har sequence, right? So if we need to work with UTF-16, kind of strings, then basically strings are haram. Can't touch them, because why? Because they are immutable. Once you have an instance of your string, it will always be that particular string. And so when you are, for example, parsing SQL and you have a tokenizer, if the tokenizer is emitting strings, it means an object per each token. You don't want that. And then some utility things like parsing and printing numbers. So it means you have an integer as a number, and you want the text representation of that, right? So you could, again, in Java, you could have some like string builder and append double, and that would print it. But then what you do with the string builder, right? So we have something called sinks. Should I say it? By the way, Martin told me that I have no time limit, so if you need to pee, please go. So we have this string sync, or bunch of sinks, which is sort of like a string builder, which also implements the har sequence, and then you can, so it has this har add and blah blah blah, and then it has methods like put whatever, right? So typically, if we want to print a bunch of doubles, for example, when I don't know, emitting JSON, and we need to format a number or whatever, then we have some implementation of sync. This one is on heap, so sometimes we use that, sometimes we use some other implementation of that sync. Yeah, quite a few. And then we call put double, which calls some utility method, which does some double thingy. And then there is some craziness, because printing a double or floating point numbers into string is surprisingly difficult. Yeah, so that was an example why, and parsing is the opposite problem, right? You receive a string and you want the IEEE 734, I think, representation of that. So that's the opposite thing. Okay, yeah, you have a question?
Yeah, may I? Is there some parts of the standard library that you really like, that you use, or you replaced everything?
Now we use some parts.
And SDK of QuestDB is open source, that anybody can use it?
Oh yeah.
And are there somebody? Do you know about somebody that would like start like using it, or somehow like?
Yeah, you mean the SDK?
Yeah, SDK. Yeah, some other companies or open source
the standard
projects.
library. I don't know of anyone using QuestDB Jaro, that's what it is in Maven, for the sake of that library, right? Because it's specialized, it's not very well documented, because it's meant to be for internal consumption. There are people embedding QuestDB in their own products and projects, but they tend to use more high-level interface, right, rather than just the standard library. Because if you need a parser for doublers, if you need a specialized primitive collection, there are libraries for that already. So it would be an overkill. The question?
Yeah, you mentioned that there are products which are embedding QuestDB. Is that a usual and supported use case, or is it something?
Embedding.
Yeah, embedding, or is it something?
It's not usual.
Like non-standard. Yeah.
There are users. There are not many of them, right? Because our official interface is guaranteed to be stable. Is this Postgres wire protocol in Flux, some REST interface with JSON and whatnot, and the API for embedding, it's mostly stable, but there is no guarantee on that, right? So if you embed QuestDB into your Java application, where it makes most sense, there might be some extra maintenance burden. Basically, it's liability.
Yeah. So if I were to ask you, like, should I embed QuestDB into my application? Like, what would your answer be?
It depends.
Okay, so it's not like something you discourage, like, because it sounds like it's a kind of a major pain point for you, that you would rather not have such people.
Originally, when the project, as you could see, was you know, the first commit is for 2014, and for quite a few years it was like a hobby toy project of the founder, right? And he didn't know what would be the result of that, right? And at some point he realized, oh well, I could build a company around that. You know, people use that, and I think back then there were, like, I don't know what was the ratio between people using QuestDB as a server and people embedding it, but definitely over the time it seems to me that the embedding part is a bit de-emphasized, right? Most of our users are Python users, by the way. Some Go users, Java users, but Python, I think, by far, because it's you know, for analytical things, it's somehow connected, right? Did I answer your question?
Yeah, you did,
Okay,
definitely.
okay. Oh gosh, we are here until 10 p.m. Not sure if we can finish. How many beers we have? Good. Not enough. All right. Okay. Okay. So I was talking about pooling, and normally when I think of an object pool, I think of some kind of interface which will give you an instance of an object. I used an instance of an object like connection, whatever. And after I no longer use that object, I will return that one object to the pool. Our pooling typically is different. And I said that one of the use cases is a parser. So let's have a look. So this is a handwritten SQL parser, not generated, which I still can't decide whether it's a good thing or bad thing. And this is the part which is responsible for parsing the table name. Select something from table name, right? So it's here. So there is some kind of lexer. It gives you a token, car sequence. And then we do something to strip schema, because we don't use schemas in QuestDB, but some Postgres clients do public dot to strip it. And then what we do, we assert that there are no slashes and other nonsense things. We pass to this assertion, we pass the last token position from Lexer. It's used for error reporting. One of the advantages of handwritten parser is that we can have nice and descriptive error messages. It's typically not the case with generated parser, typically. And here's the interesting part, right? So once we have the table name, then there is expression node pool. So if you have ever written a compiler, you have a computer science training or whatever, then you know that when parsing stuff you build, typically, not always, something called abstraction tree. What is the S for? Syntax. Abstraction syntax tree, which is a tree, which is a graph. And the natural way to model a graph is by connecting objects in Java anyway. So that's what we do. So we need nodes which we connect usually with other nodes. To have a node, instance of node without allocating, we use pool. So we ask the pool, give me the next object. The pool checks, oh, is there still some? If there is not enough, just expand. Then take it, clear it, because if it's a pool it could be dirty. And we have our object. We said, okay, this node is literal, blah 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 blah. Again, last token position for error reporting. And then we set it to some kind of a abstract representation of the whole query. And this is going on many places in the parser. Actually, just a few. I'm surprised, because basically this and some other parts are building that expression tree. Maybe there will be expression parser, which will be more heavy on this. And then parser will build this query model abstract representations, and it will do optimization, planning, blah 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 blah. Eventually it will spit out a plan, which is something executable at runtime by the backend, as we are talking about it, right? And once the plan, the executable plan is ready, then it no longer needs that object, AST graph. It's so what we could do is to return an object one by one back to the pool, which we could do, and that's how pooling is typically done. But in our standard library, the object pool has a simple method clear, which is O1, it basically said, well, okay, now consider everything, consider it to be, everything acquired by color. The color is basically, I promise, pinky, that, this is pinky, right? That nobody is using this expression nodes anymore. So just set the position to 0. It means, okay, it's fully populated, nobody's using it, and pool is now ready to release all the previously allocated object for some other parsing, for example, right? So that's one way bloody hell, to use. I didn't want that, to use pooling. I never saw this before. I don't know whether it's common, but for me it was quite.
That's what I actually wanted to ask. Like, is like reusing object essentially creating pools something you employ as a common technique when you are trying to avoid like hot path allocations?
Yeah, especially in the front end part, because in front end some kind of object instantiation is maybe not necessarily. Maybe we tried harder, we could avoid that. But the modeling a graph as an object graph is pretty natural, right? Yes. So and that's not the only usage of pool. There are others, but I thought that this was quite a nice example.
What was the purpose of the mutable interface that was implemented by the?
Okay, I can show you. It's basically implemented by object which has some state, and then once I no longer need that object, I'm returning it by the pool, then it basically reset the state of that pooled object to its initial state.
0 out.
Yeah, exactly. Yeah, 0 out, set to defaults, you name it, right? To make sure that whoever is going to use this object again next, like parsing next query, it will see it in its clean state, right? The contract of the query method, which, as you can see in this extensive Java doc, says. Yeah, we have quite a few implementation of this. Is that it must be, as it was just instantiated.
Also conveniently named like exactly what you think it is what it's doing.
Yeah,
and you have 0 Java doc like this. Yeah.
You do exactly. Who needs Java doc? Okay.
I like them.
Another example with this is from the Postgres protocol implementation, where the example I picked is you are a Postgres client this time, right? You send me a query. The query is returning a result set with a column of double, or floating point, 64 bits, blah blah blah. And then, as a Postgres client, you have freedom to tell me if I should give you the results in a binary format or text format. That's permitted by the Postgres protocol. If you are, for example, not PsychoPG2 client in Python, that's a real name, PsychoPG, that's a real Python Postgres client, then if you are a bit smarter than that, you tell me, hey, send it to me in the binary format, and that's pretty easy, right? So we have our record, it's in a binary, so if it's not a number, then it's actual value. So put network in. Yeah, okay, so this is the size, that's part of the protocol.
Is there a reason other than debugging why you would want to use the textual format for
It's simple. It's simple to build a Postgres client which uses text protocol.
Oh, okay, yeah, so okay, from the point of view of if you are implementing the client, okay.
And that's critical, right? If you build a database and you have your own custom protocol, you want clients to be easy to implement. We had this issue, I think, back at Hazelcast, where the client was super difficult. Client was pretty smart. It was aware of topology of the cluster, and there was eventing and super optimized serialization, but it was hard to write clients, right? It means there were no production-ready third-party clients. We had to maintain all clients ourselves, right? Because basically nobody from community, Hazelcast was not that popular, for someone to justify spending so much time on it, right? So I think that the having like two flavors of protocol as Postgres has is not bad.
Fair point.
right? So this is the binary implementation, right? So first, part of the protocol is it says the size, which says, okay, I will send you something that has the same number of bytes as double. And then I put it in the network order because Postgres protocol is big endian. Easy. It's more difficult when I'm sending you, when you are PsychoPG2 or other clients. I don't want to pick up on that. Other clients do that as well sometimes even PGJDBC. And you tell me, hey, you should send it to me in a binary, right? So here we have our sync. Sync is like this string builder, except it's not just for string, it can accept binary, blah, blah, blah. And then I put the value there, which it call, the double formatting method I already show you, and it will print it, encode it into UTF-8 exactly as Postgres clients would expect that. That means you, without allocating any kind of intermediate objects. And last technique, I will not go to the code because it's pretty much the same, or maybe I can go to the code because we have unlimited time, is casting functions, casting from SQL. So you have a data of some type and you want to interpret it as some other type, right? So QuestDB has a type called IPv4, which is used to store IPv4 address. And if I want to cast it to a string, which would be silly because most of the time it will be done implicitly, but anyway, cast IPv to string. So it's some function which returns string, and this is basically the implementation, right? So it has this field which is like this string builder, and it asks the it asks the upstream function, hey, give me an IPv4. IPv4 is nothing else than 32 bits, so we store it into integer, and then we again print it with some utility method into text without any intermediate object allocations, and then we return this mutable string because it implements har sequence, right? So the user will get an instance of har sequence and can treat it as if it was a string almost, except the caller has to be aware that it is mutable, right? So it cannot just keep a reference to that har sequence because the content of that har sequence can change under the hood. So it requires quite some discipline. Okay, another memory technique is Off-Heap memory. Do you have any experience with accessing Off-Heap memory in Java?
I have a question regarding the previous technique. So you had the single-threaded pooling. So where does the object reuse happen actually, like during that time? So you had the expander, so basically when you start a thread, when you start to parse the query, you need to allocate some objects, right? Because you're starting from scratch.
I will start from the other end, right? QuestDB database is starting. It repopulates some pools. One of the pool is pool of SQL parsers, because SQL parser is also single thread. SQL parser has a method parse, which will which accepts SQL string, and the output is some kind of abstract representation of that query, right? To build this SQL parser has its own pool of this node, of this expression nodes, right? So I'm a server. I receive a SQL. I take one SQL parser from some parser pool. I ask him, hey, parse this, right? The parser will use its own nested pool of node expressions. It will build this abstract plan. Once it's done, it knows that it no longer needs that nodes, right? Because it built something out of it, right? It was just intermediate representation. Then before returning me that plan, it's not plan, but for the sake of discussion, let's assume something that doesn't no longer, which it no longer use the expression nodes, right? Then it calls clear on that expression node pool. I'll show in the code. I think it will be clear. SQL. So SQL parser is mutable. We've already seen the mutable interface, right? So once parser is done with that particular query, there is something external calling clear, and that will clear all that pool it may or may not use during that particular parsing exercise. Does it make sense?
Okay.
Another question.
Does make sense. It's actually pretty smart. I have a question. Like, this points to the fact that everything is heavily pre-allocated, right? What happens if, like, for example, because of the load, I need to parse bigger queries and I run out of food? Like, is there a way how I can allocate new ones even during the runtime still?
Yeah. When the object pool is created, it's precised to some default size, and then when you ask for a new object,
oh, it expands. Okay, so it essentially behaves
it grows.
by the array list.
Yeah, it grows. Yeah, it will allocate, right? It will allocate at that growing time, but it will not tell you, Bob, go away. I don't have an object for you. You heavy query.
And you expand when it's absolutely necessary. So it's like, in a sense, like array lists behave in the same way, but there is a load factor, right? You usually don't expand when you are when you've completely failed the underlying allocation, but you do it a bit sooner. And in this case, you are exhausting all the resources.
I think it expands when it's the position is at the last one, and so it will expand when it's needed. And then I'm not sure. I think it might not expand by one. Yeah, it expands by the powers of 2.
Yeah.
And does it shrink as well when you have a lot of objects?
Not by default. Not by default, because if you are an ugly client and you send me some massive query, there is a chance that you will be an ugly client even a minute later, and you send me an ugly query again, right? Of course, when this assumption no longer holds, and you send me an ugly query, and then all the query from this point on will be smaller. It means we will have some unnecessarily allocated or large pools. Yeah.
Does it mean that you essentially lock a client to a specific parser?
No, it's more complicated because the parsers are pooled, and when the client sends a query, then we take a parser from a pool, and then because the pools are single-threaded, it's complicated.
Because you said that, like, if you are a client and you've done it once, there is a chance you will do it again. That's a pretty good assumption, but I could do that to every single parcel in the pool.
Yeah. It could be that if you have one client which is sending nice small queries and the other, that there are some pathological cases for sure.
I have a question about the clear. Why do you do it when you get the object from the pool and not when you are actually clearing the...
I don't know.
Because doesn't that add to your latency? It's probably fast, but if you do it on like a large pool,
I don't know. I don't know the answer. In theory, you could do it. I don't know. Okay, Off-Heap memory. So few people raised hands. So basically, Off-Heap is part of memory which is invisible to Java garbage collector. If I allocate a block of memory, I have a pointer which is a virtual address from the computer perspective, and unlike references, it will never ever be moved on its own because garbage collector in Java heap can move objects, but when it's Off-Heap and I know that it is on this particle, I stored something on that particle address, it will stay there until I remove it or I have a bug or something. So one way to allocate is just use my favorite unsafe, which I hope will stay in Java for many years. We have some things, if they completely ban it, it's not the end of the world. The advantage is no GC pressure, that's obvious. The less obvious advantage is a predictable memory layout, right? So instead of modeling a graph of objects with pointers or with references like in Java, we can have nice inline things we need. Again, maybe in some future version of Java, but what's called that spec, you will know too. That there is a spec to have like primitive objects, value types. I think that's called in Java. Value types.
Valhalla.
Valhalla, yeah. So maybe there will be a way to have some nicer memory layout as well. But for now, it's Off-Heap. Yeah, cache friendly. That's clear. And the other.
Which version of Java are you actually like? What is the minimum JDK version that you are?
Most of our distribution we J-link to Java 17. So when you download a package with QuestDB, you don't need to have like runtime because it's already J-linked with Java 17. But if you want to compile it, or you download version which does not J-link runtime, then the minimum version is 11. Okay, the other possibility how to use Off-Heap is to use memory map files. Do you know what memory map files is? It's basically, I have a file, it has some content, and I ask operating system, hey, I would like to have this file, the content of this file in memory. It means if I read from that mapped block of memory, if I read it, I will see the content of the file. If I write, which is more interesting, to the mapped part of memory, operating system under the hood will eventually, unless I ask him to do it now, sync it to a disk. We use this extensively as well. And once I have my Off-Heap memory, I can do tricks. One of the tricks is called a fly weight pattern, right? Because if I have just block of Off-Heap memory, then it's just some one block, and I don't know what does it even mean, what does it represent, right? So to make my life a bit easier, I can have another implementation of har sequence, which is called flyweight, blah blah blah, which accept block of memory, and then it again use unsafe to pretend that doesn't pretend it's har sequence. It is a har sequence because it implements it, but I can treat it almost as if it was a string, except the content is backed by Off-Heap memory. This is used, for example, by the Lexer. I was showing you briefly, which basically, when parsing SQL received, for example, from Postgres, we have some receive buffer, which is populated by that native networking I/O. I show you written in Java. So the receive method will populate some Off-Heap buffer, and then when Lexer can basically, when creating an instance of har, when returning an instance of har sequence, can basically say, okay, the token starts at this address and ends at this address, and then the rest of the parser can treat it as a har sequence and doesn't even need to know that it is backed by a receive network buffer.
And you are pulling these things as well?
When it's, I can't tell if this particle one for parsing, but yeah, the Lexer, there is a pool of Lexers, right? There's a pool of Lexers, and the Lexer has, I don't know if one or few instances of these flyweights, and when you ask for the next token, basically what it does, it changes this start and end address of pre-existing token instance, if that makes sense. Okay, recap. No GC pressure with Off-Heap memory, fine memory layout control, which is important as we will see later, and reuse, don't create. Another discipline, execution. Okay, we are in about half. So, do you want to have a pause? Or we want me to just continue? I still have a full, can, so.
Or just feel free to stand up and
Yeah.
like I did just now.
Okay, but before we, so feel free to grab beer, help yourself.
Definitely, we don't want
nice.
to limit this by time because it's interesting, I suppose, for everybody. So just grab something, sit back, and we are going.
Okay, so one question at the beginning from you was about analytical databases, what it is, or what is time series database. Sorry, not I don't know what is analytical database.
Your definition of time series.
One thing one of many things they have different from transaction database is the way how they how data are physically organized on disk, right? So in transaction database, they use what's called row organized storage, where basically you have a disk and there is a row, and in that particular row are all columns for that row, right? If I have in this case 4 columns, there will be this data will be collocated in that particular piece of memory, and this will be the same for all rows, which is not great for. It's great for transactional use cases. Go ahead.
I'm sorry, but just seeing the example with temperatures, I need to ask, because you won the 1 billion row challenge, right? And somebody tried to replicate it in DuckDB. Have you tried to do it with QuestDB?
No.
Okay.
No. This is great for transactional workloads, because typically when you imagine of some kind of ordering system and I send a new order, there are not that many columns in your typical transactional use case. You have normalized data, so it's and most of the accesses are by indexes anyway. It's point lookups typically, but it's not great for analytics, because in analytics, imagine now suddenly I want to see an average temperature through all rows, right? Then I don't want to scan all the other columns just to flush them away. That would be terrible. I can't use SIMT. We'll see later what SIMT is. So the columnar, I think all these days, analytical databases, they use columnar organized storage, which basically means in one file, in some one block, in our case it's file, I will have all values for one column, right? In the other file or other block, I will have all values from another column, etc., etc. The advantage is clear, right? If I'm interested only in temperature column, I don't need to read the other from disk, which is slow, especially if you are on EBS. It's cache friendly, because I don't read what I will just throw away. And again, SIMT, we'll see this later. Particular twist of QuestDB, and I think many other time series databases, is that the data, not only they are columnar organized, but they are also ordered by time, right? So physically on the disk, I know that if this is my file, the oldest one is the first record, and then this one is a bit newer, etc., etc. This puts more pressure on the writing side, right? So we need to make sure that the readers can rely on this invariant that is always ordered by time. So the writers have to be, the ingestion part of the database has to be smart. It needs to do, we do some batching. Sometimes we do copy on write, because imagine that we have our data already written, and suddenly we receive something older, right? And we already have something newer in our file. So what we can do, for example, copy on write. Then we create a new copy of that of these column files with this new data inserted. The readers are not obstructed. It's log-free, so they can read the old version. Once we do this copy on write operation, we have this new version with all the data inserted somewhere in the middle. Then we commit, and the commit will basically flip the versions. So the readers, queries really, arriving later will see the new version. It takes time, right? Copy and write can be expensive. So there is some other trickery to minimize this from happening. But the gist is, this is the key invariant. And then, it's, I think, obvious why is it good for time series databases, right? Because then when I want to see just the latest records, which is often the case, then I don't need to read the older data at all. I just need to locate the oldest row still matching that time filter, and then I know everything older than that, and this direction is older. I don't need to touch it at all, and everything from that point to the end of that file is new enough, and I need to do whatever I need to do, like scanning, aggregations, blah blah blah.
So physically, the newest data is at the same place all the time.
Yes, you could add, but it depends what you mean by the same place, right? Because the file is growing, right? So
Yeah.
and let's say I have there is some partitioning, so it's more complicated. But let's assume that there is no partitioning,
Yeah.
and I have just a file, and I call it append, 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 append. So I know that the freshest, if you will, data are always by the end of the file. That's what I know, right? So if I'm only interested in the
Oh yeah.
in the latest row, then I know that in every file it is the latest record. And if data they have fixed size, like integer, double, IPv4, whatever, it's easy because then I know how many rows is in this particular file,
Yeah.
and I know the size, and I can directly read from that. If it is something with variable length, like string, varchar, blah blah blah, then I need to do some trickery with indirection. But let's because we have time only until 10, so let's not go there. SIMT. Have you ever heard about SIMT? It's an acronym, single instruction multiple data, and that pretty much describes what it is, right? So imagine that I have two arrays, same length, arrays with some numbers, array of integers, and I want to calculate. The result should be another array, which will basically do a sum of elements on the same indexes, right? So this would be the scalar implementation. I take the first element of the one array, first element from the other. I do the sum, and I have the result. And you know, if I have n elements, then I need to do n operations, n summing, right? In the naive case, vectorized. SIMT instruction is basically an extension of the Intel instruction set, which introduced new instructions, new registers. The registers are massive, right? Normal register, you know, in the original 86 was 16 bits, right? These days we use so-called 64-bit computer, so you can assume that this word is 64 bits. In the SIMT registers, they can be up to 512 bits in size, and once I populate the register, so I populate the register with the full vector, I populate another SIMT register with the other vector, again up to 512 bits, and then there is a specialized vectorized instruction which will calculate the sum on all these items in one cycle. Again, in modern CPUs it's hard to tell what cycle is, but you know, as one operation. So I can do basically multiple operations, or one operation on multiple pieces of data at once, which is good for things like filtering, right? You know, if I have my columnar organized storage and I know that this file has nothing else but temperature or price, then I can use this SIMT trickery to find all rows where the price is equal something, right? Because there is a SIMT instruction for that. How to use SIMT from Java? Good news. I have good news and bad news.
It's not done yet.
Depends on your definition of done. The good news is that there is a JEP for this, and the JEP was created in 2008, 18, so 7 years ago, more than 7 years ago. People are working on it, and the goal is to give you Java API, idiomatic, safe, right? Which will do exactly this thing, right? It will populate something quite fat with multiple data, and then you say, oh, I want to do these and that operations, and
You said that you work with Java 11.
Yeah. So this is what I'm describing in Java, right? And that's
Okay.
what we use.
Oh.
But there is a hope that one day it will be in Java. So this was the bad news. The good news. The good news is that there is a JEP for this. The bad news is that as of now, it's in 10th incubator, still not even preview, right? My goal is not to shit on maintainers. It's incredibly hard to come up with API which will be expressive enough to use all the power of the SIMS instructions, and they are different on Intel, different on ARM, so it has to be abstract enough to work on multiple platforms. At the same time, you know, if you build too high level of abstraction, then you will not probably use most of it, right? And it's really hard to build it safe and fast and in a way that people will want to use it, right? So it's incredibly hard. I think in .NET, if I'm not mistaken, in .NET, I don't know if they have some platform independent abstraction, but they definitely exposed platform dependent instructions. So in .NET you can say, oh, you know, screw multi-platform compatibility, I'm now using Intel only, which is much easier to build than what the Java folks want to do. So your point, we are based on Java 11. We don't have an access to any of this, and I'm not sure if we would use something in incubator really, maybe. So to use these SIMT instructions and to have to get this nice speed up, we build our own JIT for filters and some other things, but mostly filters, right? How we build it? So I was already talking about the front end of the database. So the front end of database, it gives us this AST tree, right? And once we have this AST tree, then there is a front end of JIT, which first analyze, okay, is this filter even suitable for JIT translation to a native code? Because there are some conditions. Not all filters can be translated in that way, but if it can, this particular filter, really think of a very close when I say filter, that it can be, then there is a front end written in Java which emits some intermediate representation of that filter. It's no longer AST tree, it's less abstract, more concrete, if you will, but it's still not a machine code to be executed on a target CPU. So it spits some intermediate representation into Off-Heap memory, and then it goes backend written in C++, which will read this intermediate representation and will emit machine code which corresponds to the filter. And then once we have this, then we can call it while executing the query. Instead of screenshot, what was the name of that?
Does it mean that you are either locked or perform significantly better to AMD 64?
Yes, that's correct. Yes, one of the disadvantages of our approach, for one, it was a lot of work, a lot of debugging work, and for second, as of now, we emit SIMT instruction for Intel and AMD only. And if you are running QuestDB on ARM, for example, or Raspberry or Ampere or whatever, then it will not use JIT. So that's one disadvantage. The library we use, SMT, ASM JIT, which by the way is maintained by a guy, Czech guy. I didn't know, I realized it recently. Then in the newer version that we have, it can emit even ARM Neon instructions. So maybe one day.
Yeah, I was asking because like ARM instances server side, I started doing more right, like in AWS or whatever.
We are watching this. So I will probably not go to code in the interest of everyone. So just a screenshot of the front end of JIT. So basically, it receives this expression node tree, which represents the filter. So it's basically graph representing that predicate. And there is some traversing algorithm which traverses that tree and will emit that intermediate representation of the filter. And then this intermediate representation is processed by C++ code, which will actually generate that machine code which later will execute. A little detour. Sometimes people say that QuestDB Java looks like C. then this is QuestDB C++, and it looks a little bit like assembler, so everything is balanced still. Performance impact of this. So when we first, not we, it happened before I joined. When my colleagues first implemented JIT for filters, this was the result. So this was this query. I think I was showing you this before. And without JIT, the execution time was 150 milliseconds. Again, the whole table has 1.6 billion zeros. Then after applying this cheap time filter, it still has 13.5 million of rows which has to be filtered. Without JIT, it took 150 milliseconds. With JIT, 35. And I can do a demo. How fast on our demo it is now. I think I already showed you. So first execution was 30 milliseconds because there was compilation, blah blah blah, and now when I'm calling it again, it takes like 6 milliseconds. Why is it so much faster than here? Because the original JIT was single-threaded execution. Now we added another thing. For, basically we now do multi-threaded filtering, so it's even faster than these numbers. Yeah, why it's faster? Very quickly. This is how the execution looks like when JIT is not active, right? So we have some hasNext method of some operator which has base, like upstream operator, which has also hasNext. hasNext as a side effect will move pointer inside the record to a new data, and if the filter if the record matches the filter, then we return true. Yeah, there is next, and we already know the record points to that data. Yada yada yada. And the actual filter is a graph, object graph of functions nested into each other. In this case, it's simple. The graph is flat, right? There is just less than comparison, and it's comparing a constant again database column, right? But it could be more complicated. Imagine OR and AND conditions. So the graph could be quite complicated, and it would be interpreted. There would be a lot of virtual calls, and it's slow. When we generate the JIT, there is no virtualization because the JIT is specific for that particular predicate, for that particular filter. It's directly targeting that query. There are no virtual calls, of course. So that's one reason why it's faster. And just a fun fact, that's how people sometimes ask, how do you call even your own generated machine code from Java? Well, the answer is easy, right? Because we use JNI, and JNI then that there is a C implementation which one of the arguments receive address of that generated function, and it receives bunch of pointers basically pointing to the data to be filtered, and that's it.
Do you have something in between? So on one side you have the interpreted execution of the AST, and on the other side you have the JIT, which is basically generated machine code. Do you have something in between, like generated bytecode for something? Oh, right.
Exactly what I'm talking. I want to talk about now. It is the other trickery in our arsenal. Is generating not directly machine code targeting a specific CPU, but sometimes we are lazy and we generate only the bytecode, and then we rely on hotspot to actually compile that runtime generated bytecode for the target CPU it's running on. And the one way we use it are comparators, right? So imagine SQL with order by. Do I have it here? Yeah, I have it here. So again, from some table, and I want to order it by 3 columns, and one is in another order. This is roughly how it would look like without code generator, right? So the compare method would receive 2 records. It would receive order of which columns to order at all and in what order, and types of these columns, right? Because the record method has a bunch of methods like get string, get long, get double, get type. And then there would be some kind of a loop with a massive switch case for every type. And okay, if that particle it's slow, it will be a lot of virtual code. The code is not neat at all. It's but it would work. The way we do it is bytecode generator. So we have a comparator compiler which receives, okay, I want a comparator for these types and in this order, and if it's a negative the value, then it's what's called the this I don't know the English word for that. You have ascendant and descendant. So descendant, and it generates some, then this is running once per query, not execution but parsing, right? So this is running after parse time when generating the actual execution plan. So it generates a class, blah blah blah, and then the class is something called record comparator, which has a twist from the when compared to the Java comparator. It's stateful, so it has a set left method and then compare the method. The reason is the observation. Then lot of times we are comparing one record with many others, right? Imagine that you are trying to find the maximum element, right? So how you do that, right? You are iterating over all elements, and the one which is higher, bigger than the other, then you set it as a left, and then you iterate over the other until you find someone which is bigger than the one which is current on the left. You flip it, and then you iterate over the rest, and yes, you are iterating over all your data. Then the frequency of these flips will become rarer and rarer and rarer, right? That's some logarithmic something. And the reason why we do this is that it takes some time to extract that fields. If we know we are comparing on 3 fields, then for every record for comparison we need to extract these fields. And if we cache it, if it's stateful, then we do it only once per assignment to the left. Yeah, so this is roughly how the generated bytecode from this comparator compiler would look like if you decompile it. So it has this set left, it has a synthetic field for each column we are comparing on. So when you set the left record, it will extract that field, and then for compare, it's just nice, relatively nice and neat code, no virtual calls, specialized for that particular comparison. Yeah, that's basically the same. Okay, we are going to. Yeah.
Question about still about the bytecode. Are you using any library for that? Probably not.
We don't. We use this. What's called bytecode. I will do this. I will open this one. Bytecode assembler, and written. And it has basically bytecode method which is dumping that bytecode to memory, and then once you have it, then you basically ask JVM define the class. Here is the bytecode. Concurrency, something maybe more interesting, less nerdy, more impactful. 80 minutes. Okay, let's consider this query. I want to run an aggregation to get the maximum temperature per sensor. So the simplest way what I can do is I have one thread which is iterating over the table, and for each record I'm aggregating by the sensor name. So sensor name New York City, it will take the current value and the current row, will look up into output map, and we'll say, okay, what is the current temperature? If it's not for that, what is the so far maximum temperature for New York City? If there is no New York City in the output map at all, just insert the current value. If it's there, then compare it. If the current row is higher, then basically replace it, easy. Super simple to implement. The disadvantage is obvious. It's using only one CPU core, and if I have a machine with 128 cores, which is not that unique these days, then 127 cores will be tumbling fingers. Is it the word?
Yes.
So one possible optimization could be, well, instead of map, I use concurrent map. So I split the input data into partitions. Let's say 1/3, 1/3, 1/3. I will have a bunch of workers, and they will use concurrent map. So if the entry is not there, again, just insert it atomically. If it's there, then do a comparison. If mine is higher than what's already there, then do atomic swap. That could work in theory, but it would not be very fast. The reason is that if you have 128 cores and they all want to write into the same area of memory, you will have in cache coherence traffic in the CPU like crazy, right? Because this 128 cores will be all competing to get the same cache line, which is the basically minimum. Doesn't matter. They will be competing to write to the same addresses, and there will be a lot of traffic within the CPU, and it will not scale at all.
But you can basically like do it like in partitions and iteratively.
Yeah, exactly.
That's basically how it's called.
Mm-hmm.
Yeah,
the reason why this is basically slow, it is at the fundamental level we are violating the single writer principle, which basically says into one particle area of memory there should be no more than one writer, otherwise they will be competing against each other. I want to write to this part memory, I want to write, and there will be a lot of this maintenance coherence traffic. You don't want that. So what we can do is, what a smart guy, aren't you? That you can tell by the Fedora. Is it Fedora?
Technically, yeah, slightly modified one.
All right. So yeah, the obvious improvement is, okay, so if I cannot have my workers competing for the same map, so I will give a private map to each worker, and I will still split the input data into thirds in this case, and each worker will build its own private map, and that's nice because that's parallel. They don't compete against each other for the same memory because input is segregated, output is segregated. That's not nice.
Basically map reduce.
Yeah, but then what? Then if I have the temperature for New York City in this partition, and then I have a temperature for New York City in this partition, then I will have it here, I will have it here, and I still don't know what my maximum is.
You need to combine.
So I need to merge it. And if I don't have that many unique records, it's not bad. I can merge it, it will be fast. But if I have billions of sensors, then this merging step will become a bottleneck. Because I need to merge all, I can do, if I have many maps, then I can do some intermediate parallel merging, but at the end of the day, I will end up with two maps, and I need to merge them. And two maps, I need to merge them, well, most likely in a single thread, and that will be slow. So it's a scalability bottleneck. I want to avoid that. What we could do is to go deeper. Each worker this time will not have a single map. It will have multiple maps. Let's call it map shard. And each worker is still, reading from its part of input data. It knows the key, which is, the sensor name. It calculates hash for that key. It does some operation like modulo number of shards, 4 in my case, because each worker has 4 shards. And it, let's say, hash code of San Francisco is 7, then it does modulo 4, which is what, 3, I hope. So it will be this map, right? Third map. If this worker has San Francisco in its own portion of input data, then it will also end up in the same shard. It is physically different map, right? But it's shard number 2, right? Does it make sense? Are you with me?
Okay.
Okay, good. So I will end up with this. I will end up with a bunch of threads, and each thread will have a bunch of shards. And I will know that if this thread has San Francisco here, then this thread, if it has San Francisco at all, it must have it here too, right?
And then you can just.
So what I can do
it on the
is
same
then I
shard.
can do this parallel merge. So this can be one thread merging the same shards, and this will be the result for all shard 0. I can have another thread in parallel merging these shards, and this will be my result. So at the end of this process, I will still have 4 maps, right? That doesn't look that great until you realize an important property. If San Francisco exists at all, then it will be exactly in one of these sub-results.
And you can just concatenate this.
And if I want to iterate over all results, I don't need to merge them, right? I can just
Go from
iterate
one to-
over this sub-map, right? And if there is a San Francisco in this map, then it will be the global maximum, right? And then once I exhaust this map, then I can iterate over this map, this map, this map. So there is no merging bottleneck.
What I find really interesting on this is that actually it's pretty smart. Like it's the exactly same principle which we use for storing data and charging them, but put into the execution engine.
There are some pathological cases.
Yes, but like on a kind of like an abstraction level, it's pretty similar.
Yeah. No. But I wanted to say that if you could find pathological cases when I have a bad hashing function, and there will be some imbalance, right? So some threads, some workers will be more busy than others. So maybe it's not a good idea to have just 4, right? Maybe I should have, but in practice, this is what we have right now. There are some optimizations we could do on top of this, but that's what we have now, and it worked quite nicely. Okay, so we went through these 3 disciplines. What else we have? We have some myths to bust. One myth is that JNI is slow. It's not, unless you pass full-blown Java objects between Java layer and native layer. If you pass full-blown object, that can be slow. Depends what you mean slow. But if you are only passing primitive types, like pointers to memory, then the cost of a JNI call depends, but it is in small nanoseconds, typically 5, 7, 10, something like that. There's some benchmark done many years ago about this. So it's probably not smart to call native code in a tight loop. Then some batching would be probably needed, but if you call it every now and then, generate a filter native code or execute this filter on this block of data, then it's, you will not notice that. Yeah, real world example. I think we saw this. Similar. I think it's similar. Let's try to execute this. I think we executed exactly this query. Some time series specifics. So I said at the beginning that we support SQL with some time series specific extensions. One of them is sample by. So basically this. I don't have it. No, that's not a good one because I don't have sensors table here. It's artificial. But I want to show you sample by. But I cannot because, yeah, here are example queries. I can't see where it is. Okay, let's try this. So we have another table which is called on the demo, which is called traits, which has live crypto traits from, I think, Coinbase. Not sure. Don't really understand crypto, but that's a live table, and we are continuously feeding data there. So right now it has slightly under 2 billions of columns, ending with 636. If I read it, so it increases. Oh, maybe I have it here. No, I don't. I have it. I have it here. So I have this traits table, and I want to see the traits with this instrument today, and I want to sample this by 15 minutes bucket, and I want to see the first price in that 15 minutes bucket the last price, minimum, maximum, and the volume, right? And if I executed it, the first execution took like 18 milliseconds, and here is my result. And the result is just 71 rows. If I sample it by 1 hour, it would be something like this, because it's not the end of the day yet, and it's in UTC, or I can do it by minute, and yeah, it's all fast.
Can you do it for a week ago?
Oh, I could, but how? There could be something like date, diff. Oh, but I don't remember what they do. But I can have a look to the documentation, because I know how to program QuestDB, which is a SQL database, but I'm really terrible with SQL. So I could do something like this. Is it that one I want to use? No, that's not the one. I'll show you later. I don't know the SQL function. Maybe this. Yes, this will be the one. Date add. Timestamp in, and now what happened? I will take date add, so it's to something like this. I think there is D. So take the current timestamp and add -1 day. Let's see. Huh? Something is wrong. Let's try this. I don't know what I'm doing wrong. I will check later. I probably have the syntax mismatch. So something is bad. Hey, after 90 minutes, we are close to the end. The lessons learned, at least for me, is that Java is not really a bottleneck. You ask about the performance comparison between us and DuckDB. As I said, in some queries they are faster, in other we are faster. DuckDB is written in C++, modern C++, I call it modern C++. To get the speed, you need to have some kind of like mechanical hardware sympathy. You should understand how CPU works, at least have some idea how they work under the hood. You should not be afraid we are not afraid to break some conventions, batching of course, and we do quite a lot of benchmarking, both micro benchmarks and some end-to-end benchmarks for both querying and ingestions. And yeah, again the question is why Java? Well, tooling. For me tooling and community are probably the best part of the Java, like, yeah, full stop. The trade-offs of this is that as I said, you need to understand not only the CPU but the JVM. It needs really strong discipline, right? All this pointer manipulation, programming, accessing Off-Heap from Java is sort of like programming in C, where everything is pointed to void. If you ever program in C, it's a pointer, and it can be anything you want this to be. And so you need to know, okay, this particular pointer is pointing to an object of this type, or something like that, because in Java it's all long, and you have no type system helping you to tell, okay, this particular pointer is to what. So it needs discipline, it needs testing, it needs things like fast testing. You know, you need to generate random SQL which will execute, and most of the random SQLs will not even execute because it will not parse, because it will not be compliant with SQL grammar, but you can at least validate that, well, some will execute, but you need to validate that it will never crash, right? And so that's part of the fuzzing. So yeah, more of the same. Is it worth it? I'm still not sure. As I said at the beginning, these days Rust is quite popular for data projects and databases. The ecosystem is good in Rust. So maybe for new project, I'm not sure. What else? If you want to get involved, it's Apache 2 license. We like contributors. We have quite a few of them. Maybe I can show you. GitHub, QuestDB.
I can imagine it's kind of hard to contribute to something like this. So
Yeah,
do you have something like starting issues or?
We have a label, good first issues. Not sure how well it's maintained.
Okay.
We have Slack, so people hang out on Slack, including myself and all my colleagues, and most of the contributions tend to be small, but still meaningful. So there are some, and there are some. Okay, one thing where we see contributions is not the core database, but our clients, right? So we have clients for ingestion. As I said, we have Postgres client for querying. For ingestion, we use this influx line protocol, but we didn't really like the influx client, so we'll build our own for most languages, the popular ones anyways. And we receive quite a few, contributions to clients because the bar is lower, right? Yeah, I think that's all. So thank you for sticking here for 80 minutes. I hope you are not bored to death. Some of you maybe. Thank you for your time. If you want to see the demo, just go to demo QuestDB.io. It's open for everyone. There are some demo queries, as you could see, or you can run it locally. And that's all. Thank you. If there are any questions, happy to answer it now or later. I will probably,
Probably you can take some, so they are on recording. Like, take some questions now, so they are recorded.
Okay, so questions. Yeah,
How do you test? Do you have your own Q unit?
No, actually, we use JUnit, among others.
You're kidding.
we test with we have JUnit. We use something called, I forgot the name, SQL Lancer, which is from some Swiss university tool for testing correctness of databases. We use that. What else we use? There was something else, SQL Logic, which is another. Maybe I can show you. But I need to create this.
So allocation in test is allowed.
Pardon?
Allocation in test is allowed.
Oh, in test is fine. I recently did something what calculated the Cartesian product of many properties, and then my boss was not happy, but so SQL Logic search test. I hope I'll find it. Yeah, here. Oh, these are the demo data. I don't want that. Yeah, here are some scenarios. Basically, it's text form describing what happens when. So that's something else beyond the JUnit driven. But most of the tests are JUnit driven. But some are scenarios like this because it's just less of a ceremony. If you just want to say, okay, if I do this, then this happen. Yeah. there are some fast tests. Fast tests. And here will be the Cartesian product of something. So this is the old version. It's calculating all permutations. In the newer version of this fast test, it's always take just one permutation per execution because it was running like 1 minute. Okay, another question? Yeah.
If the Java code looks like a C, why to use Java like this? Have it like in the C completely?
Yeah, the rewriting this would be a massive effort, right? It's I think I don't have the statistics plugin here, but it's now higher hundreds, thousands of lines of code. So rewriting this would be a massive effort because it's from 2014, right? So what is going on is that some of the newer parts, typically not in the open source, but the model is that the core is open core basically, right? So the base is open source, and how we make money, we sell you enterprise version of this with some add-ons. One of the add-ons is data replication, right? And for example, the data replication is written completely in Rust, right? And the way how it works is that you have let's say primary for the sake of simplicity, and you have a bunch of followers. The way how it works in the enterprise is that they don't communicate with each other directly. Instead, the primary uploads its own wall log to block storage, such as S3, right, to some known pre-configured bucket, and then the followers will fetch these wall logs from S3 or Azure Blob Store, even NFS, I think, and will replay that, and assuming everything is working nicely and it's all deterministic, they should reach the same state, right? So, and this is written completely in Rust because it's fairly independent from the, for example, query engine, right? And we didn't want to write, even our boss didn't want to write his own S3 client. And in the Rust ecosystem, people are more conscious of allocations, right? There is stack allocation, which is not a problem at all. So there are less reasons to reinvent your own wheel, right? Because if you use a solid client, then it will not have the same issue as most of the third-party libraries in Java.
Okay, maybe I will rephrase it. Like, what are the benefits of using Java, like in QuestDB?
I'll try to make it better. Like, what were the benefits of writing it in Java at the time?
Well, okay, at the time, the tooling for C++ was shit, right? Rust wasn't there. That was in 0 point something version.
YouTube regulations.
Pardon?
Language.
Pardon?
YouTube language.
Oh, well, I can say shit. I'm a free man.
It's alive.
Yeah, you didn't have buzzer.
I will get it for you next time.
Yeah, and the maybe another reason is that back then the founder, he knew Java, right? He knew Java, so he wrote Java for a living, even in that high frequency trading shop. But that's what he knew, so he started to do that, and he told me one day that that was his challenge. Can I write a full-blown database using the same principle we use in high-frequency trading? Because the high-frequency trading programs, from what I know, I never worked in high-frequency trading, but what I know, they tend to be relatively simple, right, and very specialized, right? So that's one thing to build that. Not simple, but smallish program in this specialized Java, right? But it's something completely different to try to write a general purpose full-blown database, not specialized for one particular use case or algorithm, by using the same principles. So that was originally a challenge for him, and he can be, goal-oriented, I wanted to say stubborn, but I would that word because I'm on YouTube. If I was in his shoes, I would probably have given up, many times. But because he is so goal-oriented, he walked away, and here we are.
I have a question about memory allocations. That, where would you not mind to allocate memory? The first case was when you were talking about the readers could read without getting interrupted by writers. I understand that's when you mentioned you would like to create a copy on write.
Yeah.
And could you give us some more examples where you really would not mind to create new objects?
Yeah, one example I did just, I think, on Monday is I'm parsing SQL with a join, and the join has a on clause, right? So I'm joining on this particle 2 columns. So, I'm taking one column from this table, the other column from that table, and I'm joining on them, right? And in our case, most of the joins are on the one column only, right? Because for one reason is that in analytical databases, typically the data are denormalized, not always, but often are. So joins are not that common, and if they are, it's something like joining on some lookup table, right? So it's one joining key. Okay, that's easy. We can do that with no allocation. Joining on 2 columns is rarer, but I can still do it without any allocations, right? Because I have in the object I'm building, there are physical fields for one join clause and the other join clause, right? But if I'm joining on more than 2 columns, then there will be just an array, right? Because and then we say, okay, here is an array with my join clauses, right? And if it's more than 2, which is rare, well, there will be an allocation at parsing time. It's fine. Because there are allocations. Okay, another example, maybe simpler, is actually parsing, right? So when we are creating this physical executable plan, that plan, even it has a bunch of pointers to Off-Heap memory, the plan itself is a Java object, right? Which we allocate. But that we don't pull that because there are so many flavors of individual operators, so we don't pre-allocate that. We allocate these operators after parsing, right, when creating this physical executable plan, and then we just do new. And then we hope that you are not using PsychoPG2, which doesn't support binding variables, so it creates new different SQL text for every parameters you pass it. We are hoping you are using something more sensible client which supports binding variables. So we parse the particle query once, we create a plan, and then you just re-executing that query with just different parameters, right? So basically, assuming that creating a new plan is not that common, and in that case we allocate. Does it answer it?
Yeah.
Okay, good.
So actually recommend to really use epsilon GC for like real production deployments.
No. Because there, as I said, there will be some allocations, right? There will be some. I would not recommend epsilon for production deployment at all, because there will be. I recently discovered we have a bug, let's call it this way, where we have some kind of a query monitoring to spot slow queries, to report to users, hey, this query is slow, do something about it. And that there was some kind of a query registry which was backed by concurrent hash map from the standard library. Actually, not the one from GDK, but we have a copy from the DAC-Lee. We put it into what's called public domain with very liberal license. So we have basically we adjusted that, but it still allocates, right? And I was doing some profiling, allocation profiling, basically running queries in the loop and saying, okay, where do we allocate? And I noticed that for that particular use case, most allocation heavy was this ugly query registry, right? Because when query was about to be executed, it registered itself, I am about to be executed, and when it just finished, it did register itself, right? And this registration it allocated, right? So some, and there will be other cases like this, and epsilon not in production. That's what the hardcore high frequency people do. Okay, yeah, go ahead.
Do you have some automation that detects whether the new code is adhering to your principles, or is it all code reviews?
Yeah, I wanted to say our automation is as our CTO. No, we don't. We probably should have, but we are quite small team. It's the whole company is about 20-ish people, and that includes both us developers, but also some operational side and salespeople, and so we need to pick very carefully where we invest. At some point, I guess we will add this automation to basically assert maximum number of allocations, but right now we don't have it. That's why that query register, it slipped through. I remember after joining QuestDB, one of my first pull requests was something with, I forgot what it was. I think Java client for influx line protocol I was implementing, and in the review I got like thumbs down because it allocates, and I'm like, well, it does not. It's I was so careful. There is no single instance of the new keyword. Guess what it was? Autoboxing in Java. I was not paying attention to that, and yeah. But after a while, I've been with QuestDB for a bit over 3 years. I joined on 1st of April, 3 years ago, and after a while, you just get used to it, and you develop an eye. Yeah. So reviews, basically. The short answer. Sorry, I talk too much. The short answer is right now we rely on reviews.
Thanks.
Yep.
So probably last question. It's 2025, so no AI in your talk?
I could do.
Why? You can have it.
Do you want an AI talk right now?
I guess we are done for today. Thank you. Okay, so just to finish the YouTube, thank you everyone that was watching online. See you again in September. And for you here, we have actually some feedback form. So if you want to give him some feedback, there will be a form in the back. And you also get a free pen if you feel it. So, thank you again.
Yeah, thank you.
Bylo to super, ale já neumím psát, takže to nebudu vyplňovat.